Hey everyone, how are we doing? Here's just going all crazy today, but hope everyone's having a good evening. It's 4 p.m. in Knoxville. We're going to start up some coding in R here in a moment. We've done a lot today. It's been a big day. Charles got a question. Brian, can you go over the product question again? I just scored a screenshot of my issue trying to run a subset. I loaded the product. Can you send me your code, Charles? Send me the code. Let me look over here for Charles on the Discord. And thank you so much, Charles, right there. I got it right here. Can you send me your code, like as a... Okay, so send me your full code. I see you're making a product. You're making a subset right there. You said, for this one, when I try to make the subset and run the code, it doesn't populate the numbers you got into the bottom. So it looks like it's making a subset. So it looks like it's making a subset. Thank you, Charles, right here. We're putting a little chill music. So that looks like it's working. Let's go take a look at this right here. And let's label this. Let's label this 4 loops. So 4 loops over a product failure. Okay, let's take a look at this code right here. Here we go. Okay, so we're going to work with a for loop right here and get it to tell us how often a product failed. So if you're doing this example with us right here, we need to make sure we have library reg class loaded up. Now, if you don't have reg class loaded up, you have to make sure it's installed. So this loads a library from downloads, installs it from the CRAN server. I'm not going to run it because I've already installed it, but that's what that code does right there, and I'm commenting it out so it no longer runs if I were to run it. It's just a comment now, which is just, hey, here's a thing, but not actual code. Now, this loads the library reg class, which is just a bunch of stuff. What do we mean by stuff? Well, we can look inside of reg class right here by doing the double colon. This just tells us what reg class has inside of it. It also has some data sets, but there's the variance inflation function, the QQ function right there for QQ plus for normality, C models, all this great stuff for doing stuff with regression mostly, or fun like outlier demo stuff. So all this stuff right here is inside the reg class package. So it's just a bunch of stuff. Something else it has inside of it is the product data set. And you can tell the product data set's inside of it because it says reg class right there. Like the US personal expenditure is inside of the datasets library. So you have to make sure you have datasets loaded up to use this one, but we're looking for the product dataset, so it's very important we have reg class loaded in. So are you good right here, Charles? Put a yes or no in the chat. Are you here right here with me right now where product is in your global environment? How are we looking on that? Product exists in the global environment. So this loads data sets from packages that are currently attached to our base. This loads the library. Now we're asking it to load. And then this installs libraries from your server, your repository rather. You're right at the top right there. Now what you want to do now is we're actually creating a subset. So this code right here, subset product, where categories equal to A means, and let's take a look at the code or look at the data. We have inside of product what is called category. Category is a vector, and let's look at it first right here. Product, we're going to let it autocomplete, $category. So this is a category ABCD that the product is a part of. By calling the subset function, we are saying, I want to make a subset, and the first argument is, what are you subsetting? Well, I want to make a subset of the product data frame. Then the second argument right here is, what condition do you have for it? I want only products that are products logically equal. And I say logical equals because it's double equals. A lot of great questions that were asked today were what's the difference between equals and equals? Equals is a logical test to say, is it equal to this? It's a little bit longer than equals, which is just assign the number 2 to the value 5. And I usually do things like this. You're noticing we're getting errors because I'm trying to assign the number 2 to be 5, and ours like, yeah, you can't do that. Usually we assign things like 5 to the object 5, and then thus it creates in the global environment. So that's just a review of what we are saying here with the double equals for a logical test to ask if it's logically equal to the string, if you know, it says string right there, because these are the string right there. Okay, so now that we have this, let's take a look if it runs. That creates the subset, but why is it not occurring over here, Charles? Why does this not exist over in this world? Why do we not have the subset existing in the global environment, and how can we fix that? So I run it, and it runs, but so it runs. That's good. It runs, but I want it to be over here. I want it to be over here. Now maybe I don't want that 5 thing. A lot of ways to get rid of 5. I can go RM5. That removes it. So that removes it. How am I going to get this to here? How would I... What code would I need to put before this to get this over to here? Remember, we got MuBot here, so we're dropping points in the chat. So if you've already talked, you get those points when I drop MuBot points. So what do we need to do to get this? We didn't store the subset as a object, or yeah, I guess variable. I call it objects usually. So let's call right here sub stored as this. So now it creates. That just says take whatever you have right here and store it. Great job, Meath, right there. More points in the chat. Hopefully this is making sense. Please slow me down if I'm going too quickly, but we're trying to do it in steps. This right here says store whatever this is right here into this thing over here on the left. So now that we've got the subset created, we actually want to look at what's going on with the outcomes of this subset. Now I'm only looking at product A, and for my subset, how could I just look at the outcomes? I just want to look at the outcome of what's happening with A. Could we also go with the question? Yeah, let's use that next. You got it, Sophia. Let's do it next. You got it. For me, when I run my subset, it shows it in the coding chunk instead of... Oh, yes. So if you want to see it in the console, do the following. Go to Tools, go to Global Options, and go to Appearance. No code. Go to our Markdown. Right here. So let me show you where this is at again. You want to go to Tools, Global Options, Tools, Global Options, and then go to our Markdown and uncheck this box right here. That says show output in line with our Markdown documents. I don't like that personally. Sorry, I made some changes to I like to see it in the console down below. So if you change that right there, Charles, thank you so much for asking. Keep those questions coming because that will change it. If you uncheck this box right here and you click apply OK, yours will now be like mine, and it will now show it in the bottom console, which is the way I prefer to see my output. It's confusing to me when I run it and it appears in the chunk below. I just prefer to see it down here. There's like a preview in the chunk below. So that should fix that. So now we've created the object sub right here. Sophia will be doing yours in about 5-10 minutes here, so keep it up. Good questions. So now if we have the object sub and I want to look at just the outcomes, how can I just look at the outcomes? Don't code everything yet. Let's just look at the outcomes of the subset. So go to your sub, the object sub you've created, and just look at the outcomes. Just do that. Just look at the outcomes of your subset. So you want to go to the sub and look at the outcomes. That's all we want to do. Think about how to code this. Just go to the object sub and go within it and look at the outcome. Always think about it like you're communicating what the computer's going to do. Go to the object sub, so do that, and go within it. Well, go to the object sub, go within it, and get the outcome vector. How are we going to do that? How are we going to do that? Give it more and more. Don't worry, take a guess, or I don't know is a good answer too. No idea, 100 points right there. We're going to go to the object sub right here. There we're at the object sub. And then how do we get inside of it? Take a hint over here. How do we go inside of data frames? You got it right there, Meath. And how do we go inside? What is it? Great job. Shreya right there. 100 points. You got it. We're going to do $, and then we're going to do right here the $sign to go inside of it. And we're going to get the outcome, and those are the outcomes. Now, what's really cool is we can just highlight the code and say, you know what? I don't want you to display it all. I'd like, and I bet you got this one. You ready, Charles? I'd like a table of that. I would just like a table of it. Great job, Meath, right there. I'd like a table. So what do you think I should write at the start? I highlighted my code, and I'd just like you to make a table of this. Like, tell me a table of the values, like how often this occurred and how often this occurred. So what should we do if we want a table of it? What should we do if we want a table of it? Table. There you go. Now, it's really interesting, and I think there's an argument to make it a relative frequency. Let me see. I didn't do this in class, but I'm going to do it here. Relative frequency table in R. There's like a quicker way. They're doing the length, but there's such a quicker way. Does anyone want to drop in the chat? They're doing the length. I know someone showed me a way to do this. And there's like a quicker way. Everyone's dividing by length. I mean, you can do that. I just want to do it the fast way. And then I want to memorize how to do it. Well. There we go. Lots of ways to do this. You could go the length of the vector, the sum of how many observations there are. But I swear there's a way to do a frequency table inside of R. And it's another argument inside of table, or it's a function. So I ran it and got the totals of what's the percentages we want to divide by how many values there are. Do you see? So the sum of the table is how many values there are. Does that make sense right here, Charles? Like when I do the sum of the table, it's adding up these two numbers right here. So I'm just taking how many values there are. So that's going to be the relative frequency. I was trying to remember the code to just, I swear there's a quick way to do it. And I maybe just can't remember it. No, that's not what we want. Used, no. Press, row names, set, base, strings, no. There's a quick code. Not even sure if you're section. Oh, you're welcome, Brent. So good to hear that, Brent. 100 points. Glad to help out. So we're just taking a relative frequency table right here because the relative frequency table is the total values divided by the sum of the values. So that just gives us all these numbers here. 630 divided by 635, 5 divided by 635. And there's the values right there. Now what you could do is you could just store these values into X. And that's just going to create the object X right there. Now, can you read what the sum argument line of code means? Yeah, sure. So this says, make a table of the outcomes. Does that make sense? And then take the sum of the table, which is just going to add together 630 and 6 and 5. So that says, make a table of the outcomes, like what occurred, whether it succeeded or failed, and then add together the values in the table. And then this says, make a table, then divide by the sum. Sophia, no, we'll make sure to do this next. It'll be recorded, Sophia. Sorry about that. Sophia, I'll do the question and I'll record it. I'll try to go slow. We'll spend like 10, 15 minutes on it. Sophia, thank you so much for being here. We're throwing as many points as we can at you right there. So thank you, Sophia, for being here. We'll make sure to do it next. You got it. So with this right here, with the object stored as X, how could I then turn this into a percentage? Like say I want to turn this into a percentage. What could I do? I've stored this as X. Like this whole thing right here is stored as X. How could I turn X to a percentage? Not complicated here, I promise. How could I turn X to a percentage? It's just called X right now. This is just X. How could I turn X to a percentage? Promise not complicated answer. Here's a hint, 100 points. How could I turn X to a percentage? Times 100, yep. And then I could wrap it inside of a what to round it. Then to round these answers, I could wrap it inside of a what? Usually the functions do what they say. Wrap it inside of round. Great job, Sherry, right there. Round. And we probably don't want it rounded that much. We probably want to go here and do two digits. So that'll answer all the questions for me and round it. Now, what I want is I want the products that failed. A table, review from both classes today, is called a blank vector. A table, which this is, it is a table, it's still the table we created, stored as X, is called a whatted vector. These are called the whats of the vector. Those are called the whats of the vector. Great job with all those answers, everyone here. The table is called a whatted vector. The table is called a source. A table is a named vector, which means, it's going to do that for us. Yep. So it does that for us right here. The code solves the answer. Yep. Because when we times it by 100 and round it, we get that answer. Great job, Charles, right there. Good practice. Watch this. Go to position fail. Named vector. Yep, good practice. It's a named vector. So I can say go to position 1 or go to position fail. Both those things are the same thing because position 1 is failed, but position 1 has a name called fail. Does that make sense? Like, it's just the name of the position. It's like you're the first house on the street or it's house Brian on the street. Still the first house on the street, but this is position fail in the vector. These are not really elements of the vector. The vector has 2 elements in it. If we go down here and look at X right here, X has 2 elements. You see it says table, num, and then it's got the 2 values. I'm trying to think what the 1D is right there. I don't know. One dimensional, maybe. Okay. So now that we have this answer right here, let's go ahead and solve the question. Because the big part about this was turning this into a for loop. We want to do this over different groups. The groups we are doing it on are A, B, C, and D. How do you know that fail was in the first position? Viewing it. Good question, Mason. I knew fail was in the first position by looking at it. And that's why we usually, if we have a very big vector but it has names, we usually won't use the position number. We'll just call it by position name because I don't usually know the where it's at. So I might say, oh, go to position fail in this vector because I don't know what position it's in. So it's safer to use the name of the position if you don't know the number, or the number could change. Really good question, / answer right there, Mason. Probably safer to use the named position because the number might be different. Oh, Ryan, they go. Oh, yes. Oh, man, Teams is so interesting. That's it right here. There we go. Oh, my gosh. Oh, gosh, okay. Oh, let's see. I need to hop out of Teams. I've got too many productivity apps or too many messaging apps. Oh, my gosh. Okay. So now the point of doing this right here, can explain the math again. I'm confused what we do. Why did we just turning it to a percentage? So we're turning it into a percentage just to store it as just depends on how we want it to be. To convert to percentage, times by 100 and then round to 2 decimals. Like if someone told you I ate, they said I ate this much of the pizza. They're probably trying to tell you they ate what? So last night they said, man, I went to business analytics and I had that much of a pizza. Say you had 0.25 of a pizza. Well, you're probably trying to say what? Maybe they said something crazy like this. They took a pepperoni off another pizza. Said, pepperoni, yum. So I ate that much of a pizza. So by doing this right here, and this goes to Charles' question, that's what they told us. So we could call this value here X, and then we could work with X right here. I had, right there. That sounds like to me, I'd have 25% of a pizza. So, but you might have had an extra pepperoni that fell off. You said, ooh, the pepperoni right there is good stuff. I like pepperoni personally. I should have told him. I was going to suggest they get mushrooms. So what did this do right here? It rounded it to 2 digits, and then we could times it by 100, and we could get 25%. And then we could also round to 1 digit if we want, or depends. But the second argument of the round function is how many digits are you rounding to? So we can control how many digits are rounded such that we can round to 1 digit. We can round to 2 digits. We can round to 3. I don't know what happens if I put 10. It doesn't have any extra digits, but it rounds to that many digits. By default, it rounds to 0 digits. So we could round just to straight 25 right there and manipulate that object X, which is what we're doing right here by taking X and then timesing it by 100 and then rounding it to 2 digits right there. And then we're finding only the fail product. Charles, how you doing? Good questions right here. Making sense? And thank you so much, everybody here following along. About to do another question here in a moment. And put those questions in the chat. This is all about coding in R and practice. So the point of this right here is if I put groups right here as something I can manipulate, then what have I done right here? Take a look. The number's changing, right? Because now I can find the answer for each group. Does this make sense? Does that make sense? Because it's changing what groups is. Groups is now D. Groups is now A. If there were more groups, I could just go through all the groups right here and find the answer for each group. Is this making sense right here? How are people doing on this? Because by writing this right here as groups and having it right here, I can just change what groups is by doing this. Well, I don't want that. And now I've changed it. So the reason we do this is because let's say we want to store an answer from this. I'm creating a blank vector for an answer. And now down here, I'll store my answer into position groups. So when I run it for A, it creates answer A. And when I run it for B, it'll store into this vector into position what? Thing it's going to store into position groups. So that'll store into this vector where? It'll store into this vector what? It'll store into that vector into position what? I mean, position groups, but it'll store into that vector where? Because groups is this. So it'll create that. It'll store into position B, right? Great job, Meath, right there. It'll store into position B. So it'll, now we run it and we take a look. We run it to take a look and it stores into position B. So, we're looking at this is the failure, right? So that's the fail of that group. And there's the successes was 5.87. The failures was 94.13. So the failures are 94.13. So it's storing in there the failures of it. So we can see the failures of B, but we can also see the answer we stored right here for the failures of B. Now, if you look at this, I'm basically running the loop by changing what groups is. So rather than doing it that way, we preferably like to take our code right here and drop it into a for loop. Now think about this. The variable is what changes in my loop. What changes every time I run my loop? Every time I run my loop, I want this value to change. Every time I run my loop, I want it to change what the value of this is, so we create a different subset. Every time I run my loop, I want it to change the value of this, which is what the variable is. The variable is the thing that changes. So every time I run my loop, I want it to change the variable to correct the variable, and that the variable is groups, right? Because that's what I'm changing. And then which group right there, great job, Mason, right there, which group. And then the groups, you can just tell me the answer, not the code. The groups need to go through blah, 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 blah. Don't worry about the code yet. The groups need to go through blah, 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 blah. Like, just tell me the values, their letters that they go through. Tell me the groups need to go blah, 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 blah. What do the groups need to go through? Like when I run it, the first time it would be this, second time it would be A, B, C, D, right? So the groups are going to be A, B, C, D, and you saw me doing that earlier when I was doing it here manually. Great job. Everyone following along. Love it. So what we're asking for, if we look at the product data set, you can see the answer. Someone might have put it in the chat yet. Not yet. That we're looking for the what of product category. You can see ABCDs here, but we should probably just go get the what's of product categories to get this ABCD thing. You can see the answer down low, and we can code it to get that answer. So we probably just want to get the what's of the product category, of the category from product. Probably just want its what's. Because we want it to do A, B, C, D, and those are the blanks of the product category. Answers down low. Those means the answers to a categorical question. We probably just want its what's. We want its answers down low. Oh, not length, levels. 100 points right there, me. We want its levels. The length, which length is every time we're going through like the positions. A lot of times we're going one through the length of a vector. That's like go through all the positions. No worries, no worries, no worries. Thank you, everyone. I'm doing 500 points. Don't worry. I just appreciate everyone was here. Everyone was like, I'm stuck. Don't worry. I just appreciate everyone's here following along and practicing, because don't worry, it's practice. And then you run the code, you check your answer, there's the answers. Make sure to practice, even if you're just trying this right here, it's good practice to make sure you get the syntax down, you know how to correct your own errors. It's about practice. So I love it when people follow along and just give it a try. And if you fail, don't worry. What do we do when we fall? We pick ourselves back up and we try again. So let's see right here. Sophia was asking about question number, the tips, tying the tip percentage for Saturday. Okay, let's do tip percentage for Saturday right here. Tip percentage, it was already a factor. Did we convert it? It was already a factor, correct. Good answers there, Meath. It's already a factor right there. We didn't convert it. It is a factor right there, the outcome. And so now, let's put a new note right here. And 26, 25. So this is for loops for tip percentage of weekday. This is actually a very similar problem to what we just did, because if we want to run a for loop to get only certain days from the tips data frame, which makes sure you have reg class loaded up. You can see it's inside the reg class data frame or reg class library. So now we're going to clear this out here real quick. We're going to run it and show that tips shows up. Make sure you have, once again, the reg class library in here by running library reg class. If library reg class doesn't run, make sure you've done install.library or install.packages reg class, and it needs to be in quotes. I'm not going to run that, but that will install it. So when you think about this problem right here, if we are trying to just talk about one day of the week, then we'd want to create a what of that day of the week. So if we want to talk about just one day of the week, we'd want to create a what of just that day of the week. Same sort of problem. If we want to talk about just one day of the week, I'll probably do some while loops next. Subset, Mason, you got it right there. Let's go here and do a subset. And the first argument of subset is, what are you subsetting? Well, I'm subsetting the tips data frame. Now, if you notice, I didn't store it. I just ran it. It's just taking a subset, but not doing anything. Sophia, great to see you here and great job. We're just taking a subset. Now, I probably don't want this to just flash on the screen. I probably want to what the object that I'm creating. Now, I'm not creating a subset with conditions here. I'm just saying make a subset of tips and just print it to the screen because it's not being this. But I probably want to keep it. How would I keep this thing after creating it? How would I keep it after creating it? How would I keep it after? I want to keep this because I'm running a bunch of times like run. I can't keep it. How can I keep this object? I don't want it to just print to the screen. I want to keep it. Store in the global environment. You're Ryan. Let's just go right here before it and say store it into sub, and that creates it. Great job right there. Store into X. Usually I call this thing sub just for my subset. You could call it sub tips, whatever you want. Some people will do things like sub underscore tips, whatever you like. Just store the object and create it. That way you still have it to work with. I classically just call it sub every time, and that's where I use my subsets at. So now that we have this, it's just a carbon copy of the tips data frame because there's no conditions here. How could I start another argument to start telling it, but I want you to do this? I don't want it to be everything. How could I start another argument to say, but only take this? How could I start another argument? What do we type to start another argument? Comma, you got it. I usually hit enter because it does nice syntax, helps me see where I'm at. I've got what am I subsetting? What am I subsetting? I am subsetting the tips data frame. What are my conditions? You can put multiple conditions in. We're only going to put one, and looking at the tips data frame, we can see weekday right here. Weekday is the name of the variable we want to use. It automatically knows we're in the tips data frame, so you don't have to do the following. Some people do. I prefer not to. We're going to do logical equals, which means we are looking for a value. Logical equals is double equals, and we're going to look for the value of Thursday at the moment. That means our subset right here is only what? Look at the code down low. What it means, our condition is it must be the weekday must be logically equal to weekday. Make sure you have a capital W, common error. And we only have what in our subset here if you look at it. And always look at the things you create. We only have what here in our subset. We only have what? We only have data for Thursday. You got it, Trey, right there. Great work. We only have Thursday. So now that we look at this right here, and we see that we only have Thursday, let's do a little helper work right here. Great job, Sophia. So what about if we don't say find Thursday, we say find day? But I want day to be Thursday. Is this going to do the same thing right here? If I say day is Thursday and I say do this, we'll do that do the same thing right there. And you can see the answer behind my head where subset is at. Will that do the same thing if I just say day is Thursday and then subset and take weekday equal to day, but day is Thursday? Will that do the same thing? Yep. Exact same thing right there. So because day is currently Thursday, so my condition is weekday has to be equal to day, but day is Thursday. This will help us out later on. The basis of for loop. Yeah, you bet, Charles. Good questions right there. Thank you, Charles. And we do have this one marked, right? Yay! Okay. Amazing questions, everyone, right there. Okay, let's see. So now we want to find the average tip percentage or tip, either which one. How do I go inside of my subset and just look at the tip percentages? How would I, you can type the start of it, There's some hints on the screen up here. How do I go inside of my data frame and look at tip percentage? There's some hints up there. We're just going to look at it to start, and then we'll take the mean of it. We're just doing it in steps right here to make sure everything's working. How would I go to my sub data set, go inside of it, and then look at the tips vector? Great job, Shrey, right there. Yep. Shrey, is it just second nature to do that right now? If I'm like, oh, go get that vector, and you're like, nope, done. Don't worry. The first few weeks, everyone's like, wait, how do we do that again? And then after a while, you're like, oh, it's just a $sign. Don't worry. I can still remember when I was first coding. I was like, how do you get the data frame vector? And he's like, oh, it's just a $sign. It pulls up right there. So now you just want the what of this. Sort of little, oh, that's a good try. No worries. Good practice. So don't worry. Even everyone here is to practice. That's why I asked all the questions. So now I think Meath knows what, and great job, Sophia, right there. More points in the chat. Sophia, great work. We're just going to take the mean of this, right? There we go. But let's store this. Let's create a spot to store this called average.tip. And this just creates a what vector for average tip. So look over here at my average tip object, and we'll put a note next to it. Creates a something vector for this. It's creating a what vector. Blank, exactly. Null, blank. Null means nothing. It has no positions. That's what null means. If you were to do something like Brian Buren, that will create something with one position with nothing in it. So the length of Brian is 1, but the length of average tip might return null, or might have 0 length. Yeah, 0 length, because there's nothing in it. So there's a difference between Brian has an NA in it and Bryn. Oh my gosh, what is wrong with me? There we go. Cool. Just an example of what null and NA mean. Null means nothing, like there's nothing there. Brian means there's nothing in that position. Or NA means there's nothing in that position. The position is missing, but there is a position. So you could do something like Brian is the vector of 2 missing things. So now Brian is a vector of 2 missing things with class logical. So that is a vector of length 2 with both things missing, but average tip just has nothing in it. So anyways, let's remove Brian from this example. Sorry, Brian, you're gone. You're gone. Okay. So now that we've created this average tip thingy, we can store to it. Let's go over here and store into average tip, but we don't want to overwrite every time. We want to store today, Thursday. This will create a what position in Thursday. Think of a something vector. When I run this, you can see that running this code now creates a whatted position. Yeah, 474, Josh, feel free to ask. What do you want to talk about? We're going to do, Charles got a question next. Josh, you can be the next question on the doc right there. But this created a whatted vector. This created a whatted vector right here. I created a whatted vector. A named vector. And all we have to do is change the name of where we're storing. And now it did it for Friday, and we can check the answer right here as we run it. And if you notice, we'll stop running it here. Number 4, homework 1, you bet. And let me know which ones. I think that's one of the like A, B, C, D, E, F, G's problems. You got it, Josh. Let's do a few of those coming up here after Charles's question. Thank you, Josh. Great to see you here. Make Josh a mod. Why not? There we go. Get all the mods here. We're going to turn this into a for loop because we just found our what right here. You know him. You love him. SQL class. Oh, no, Josh. You know him, you love him. We just found who? You know him, you love him. He's here in the chat. We just found our skeleton. Look at how excited he is. He knows. He cheers every time you find the skeleton. So the skeleton is the code that is the same every time you run the loop. The skeleton, great job, Shrey, right there, 100 points. The skeleton is the code that just always repeats. It's the inner part of the for loop, why we call it the skeleton. It's inside. So we're going to take this right here, which is the skeleton, because it's the code that's not changing. And we're just going to treat it like it is the for loop. And we'll remove that. Just keep that in your memory for the moment. For loop, drop inside our code, and reformat. Looks great. And here's our skeleton. Now we have to figure out our variable and our vector. The variable is the thing that changes when the for loop runs. So every time the for loop runs, it'll change what this is to an element in the vector, going from the first element to the second to the third and to the fourth. We'll have 4 runs of this loop. So the variable is what in my for loop. Like, what is the thing that changes? I had it there previously. You can cheat and look at my code right here to see I was changing the value of what manually. And I try to do this manually to make sure it's working. But I had here previously that I'm changing the value of what? So what am I changing the value of? Day. Exactly. So day is what changes because I was changing it through different values. So now day needs to go through what? What should day go through? Day should go through the values of what? You could just tell me theoretically. We can kind of do a little cheat right here and see. Watch this. It's very similar to the last problem. Weekday. And what about weekday? The what of weekdays? You get that. You're like, oh man, let's do the what's of this because we want to do Thursday, Friday, Saturday, Sunday. Maybe not in that order, but the what's of weekday. So there's tips weekday. We want to go through the what of it. The levels. Yep. The different answers. That's what levels are. Oh, what's up, UTK, UTK, UTK? Well, let's throw some 500 points for UTK, UTK. Well, we just finished a question. Well, I appreciate the positivity, UTK, 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 UTK. So, we got some coding done right here. We're getting all the code done. Solving all the code. Oh, man. Been a busy day. You want to see everything we've done today? Check this out. This is everything we've done today so far. This is today's completion list of all the things we've done for different classes, with office hours, with class. We got 474 office hours, 474, 320, and now we're doing this right here. So appreciate everyone working hard. It's all about that practice. Have you done 7D on homework? We could. We've got a question from Charles, and then let me mark these down before we forget. Charles wants a review, which we're going to do right here. So probably another 40, 45 minutes or so. Try to do some more. Might grab a Coca-Cola. So this is basics, for and while loop. And then the next question was BAS 474 question, or homework 1, question 4. 1, question 4. And then next was BS 474, homework 1, question 7D. Okay, let's look at this. Charles, thank you so much for your question right here. Remember, ask all those questions and ask them as soon as you want. Then we put them in the list to work on them. So whenever we have a for loop, so then would Saturday just be Saturday stored into the day? Sorry, no worries, no worries. Yes, it's going to be the value of Saturday is going to be the one you see here, and you could switch it to doing the tip instead. So let's say it asked you about tip, which some questions do. You could switch it right here and just change it to tip and have the tips right there. So some tips for the problem right there. Good question, Sophia. Thank you for asking. Ask your questions at any time here. So let's check this out. Cut it out. Okay. So now the basics of loops. The reason we call it a for loop is because it goes for a what? The reason this is called a for loop is because a for loop does what? And always use the snippets. They make life so much easier. If you type FOR and use the snippet, you get the autocomplete. Who doesn't love autocomplete? People who are not happy because they have to write all the code. So why is it called a for loop? It goes till the end of how long the vector is. So it goes for a certain amount of times. Now there are ways, and this is hints for your assignment, if I were to write here print I, and then if I say if I is equal to 5, break my loop. So let's check this out. This is the, wait, what? So this for loop got broken in half. It stopped. Hints for your assignment coming up. A logical statement or a conditional statement right there is checked to say if I is equal to 5, so the loop stopped, which is kind of neat. I should have showed this example in class too. You can see right here when I run this loop, I is currently stored to 5. Now you might say, why is it 5L? 5L stands for integer format. So that is still just 5, but it means integer 5. If you regularly type 5, 5 is of class numeric. If you type 5L, it means integer 5. It's less memory allocation, so it's trying to use I as a, I don't know, it just makes an integer sequence, which is going to be less memory than a numeric sequence, which is stored as double decimal precision. Too much computer science right there. Yep. Longest time I forgot mixing it with C and L as long. Is it C for a? Oh, it just does numeric. Right? Yep. Oh, L is for long, right? Yeah, so the long is the integer, right? Is that correct? We're talking a little computer science in the background. Unexpected open bracket. Here, I'll post this in the chat. You might have... I've never seen that error. There's the code in the chat, Charles, right there. Let me know. And good job practicing, Charles. 100 points. Keep up the practice. So, and just keep saying what your errors are. Keep letting me know, and we'll keep working on it right here. So, with this right here, if I remove this right here, what does my loop do? And this is hints for 320 assignment. This is one of your problems. When my loop starts, what does it do? When my loop starts, what does it do? This is hints for their assignment, I think like question 2 or 3. When my loop starts, what does it do? Like, what does that line of code right through there do? It says, I is going to go through the values 1 through 100. So if I start this loop, I will start going the values. Great job, Meath, right there. It's going to say I becomes 1. And then it prints I. Then it says I becomes 2 because it loops back up here to the top. Send me your code. Don't worry about the if. I'll remove the if you want and just run this right here. So try this, Charles. You ready? Type FOR. I'm going to do it very slowly. Type FOR, then hit enter. Type in I. Type in 1:100. Then type print I. Snippets are amazing. There we go. Did that work, Charles, right there? Just try typing it out a few times. Just get practice. These are things I would do when I was trying to get my for loops down to be like, okay, what goes where? We're saying I will go through the values of 1 through 100 every time this loop runs right here. So it sets it to 1, prints I. Sets it to 2, prints I. Sets it to 3, print I. And the best way to see this is to use a system sleep right here and to give it like a 1-second sleep. So you're not meant to know what system sleep is, but my computer is changing the value of I and then falling asleep for a second each time right here. So when I stop the loop, I can actually see what the value of I is. Look at how it just printed 10, and it says I is equal to 10. So you could just start your loop right here, and you don't get to see it updating, but if I stop the loop, it says I was currently equal to 3 because it set I to 3, then it put the system to sleep. Make sure your eyes are like the same case. Oh, you might have just ran this inside of here. If you just run the inner code on this without it, it'll say object I not found. Click the first line of the loop, and I'll just click the first line of the loop and let the loop run like that. You can click anywhere on the first line. A common thing I see people do, which is all right, is I see a lot of people highlighting loops or going to the end of a loop. You can actually be just, nice job, Charles, 100 points, keep it up. Charles, we're throwing you 500 points. Charles, I appreciate you being here, working on this, and doing this practice because it's tough. Charles, shout outs to Charles in the chat right there because it's all about that practice. You have to get stuck. It has to break. You have to fix it. You have to understand how to fix it, and you start getting it down. You're like, oh, man. And then you'll be like, man, I remember that day when I was like, nothing worked. And then it's like, I look at that now and I'm like, gosh, I've progressed so far. So a for loop goes for a certain amount of times, unless we break it, which is the only way to exit it, unless you hit stop. But a while loop is called a while loop. Thank you, Shrey, right there. A while loop is called a while loop. No worries, you're doing great, Charles. It's all about the practice. A while loop is called a while loop because it runs while a what? You can see the answer in the chat in the help box. A while loop is called a while loop because it runs while what? Meet everyone. All the positivity. A while loop. Keep it up. A while loop runs while what? While something is true. While it evaluates to true. So when the while loop runs, what it does is it looks at this condition and it says, is this true? So is 2 equal to 2? Print key, let's say, Meet and Shreya and Charles and Brian don't care about grammar and are awesome. So what's this going to do right here? Wait, what? Oh, I didn't run it. There we go. Ha ha. Don't. Oh, this is bad. Okay, stop. What do we do? Great job, Connor, right there. So this is going to run the condition endlessly. Connor, you're awesome too. So this is going to awesome. It's just going to endlessly run. I'm just printing it. I'm not running it. It runs in an infinite loop because the condition is always true. So a lot of times, there we stopped it. Make sure the computer, just keeping the computer busy. You can run some really cool stuff right here. Like I really like the Vegas simulation. I'm going to do the Vegas simulation from scratch right here, talk over a while loop. Then we're going to do some more 474. And Connor, if you have a question, drop in the chat. This is how to do a Vegas simulation. Let's say you're pretty good at poker and you could play, like let's say at poker, how much of your money are you going to earn over a certain amount of time? Let's say you did analysis and you say, every hour I play poker, my money increases by what? My money increases by what every hour I play poker? Every hour I play poker, my money increases by what? Negative $100. So let's say every hour you play poker, random normal, your money is going to increase. And this is pretty neat right here. We're going to take one observation from a mean of, let's say you usually increase by about that much with a standard deviation of this. So this is going to say you usually increase by about 5%, but there's variation. So it is theoretically possible that you could what? This is how much money you have relative to your initial amount. I can't believe it. We're doing so well at poker. This is, I don't know how. Did I make an error in my code? There, finally. That was weird. Finally, and that stands for random normal. Grab a random normal number from a distribution with a mean of 105. So grab one number where the mean, so this is how many values? This is mean of distribution. And this is standard deviation. So finally, we ended up with less money than we originally had. Does that make sense? We do love randomness here. So we finally would end up with less money because watch this. You ready? I'm going to store this value as change. So this is how much my money changed. So if I start here with money of $100, I could figure out how much money I have after 1 hour by multiplying it by change, and that's how much money I have. Who's following me with this right here? Error in unused argument. Oh, you have an extra comma, 0.05, 0.05. So you want 0.05. You have 1, 5. You have a third one. So the first argument is how many values. The second argument is what is the center of the distribution. The third argument is what is the standard deviation. And what this is doing is it's taking a random normal curve with the parameters we assign to it. So we have a mean of 1.05, a standard deviation of 0.03. So each time it goes down 0.03. Who thinks they understand right here that this is just going to grab a random number out of this curve for us generally between 0.96 and the upper numbers over here. Does that make sense with my horrible drawing? We could show it on the David M. Lane, probably a little bit nicer drawing-wise, but it's going to grab a random... Yeah, Charles, great job. I'm doing a more complex, like 474 example right here and doing a different Vegas example. It's going to say the mean of the curve is 1.05, the standard deviation is this, and we're just going to select a random number out of it. Does that make sense theoretically? It's just going to say pick a random number out of this curve. So when I run that code right there, all this code does is just pick a random number. So it's just picking a random number out of that curve. And I was shocked that none of them went below 1. We finally got a pretty low one right there. Just says go to this curve right here and pick a random number. Just pick one random number somewhere on this curve. We're probably going to get numbers near 1.05, which means we get about 5%, because it's random if you win or lose money during an hour. So we're going to do a simulation right here in a moment to see us playing poker, and we want to earn, let's say I want to earn, we could have that we lose money. It'd be interesting, right? I want to earn, starting with $100, I want to earn $1,000. So let's go check this out. You ready? How many hours would it take? So we need to store our money value, the next one, into position 2 of our money vector. How could I take and store into position 2 of my money vector? Money vector only has length 1 right now, but how could I store into money vector position 2? How could I store into money vector? And this kind of goes to your next assignment, doing things like this right here. How could I store into money vector position 2? Because that's what I want right here. I want, like, after I've got $106 right now. So how do I store into money vector position 2? How would I store into that? Great job, Meath, right there. Yep. Money position 2 is equal to this. Now, money 3 you would think would be equal to this. Now, we want to rerun that code up there that creates a new value and then run this. But we got a problem now. What's the problem right here and how do we fix it? Because probably need to do a little change right here. So, and great job, Trey, right there, and Meath. Because we don't want the money vector anymore. We probably want to take and do the change of by what? So we probably want to do the change and do what now? Like, multiply it by what? I don't want to multiply it by money vector. I want money vector what? Because I want to know how much I have at the end of the third hour. It's just kind of in the chat. So I don't want to multiply it by the money vector. I want to multiply it by... It's kind of already in the chat. Because if I multiply by money vector position 2, yep. Because I want to multiply what I had and check it out. That then puts in there what we now have for position 3. And Meath, I think you're seeing it. But watch this. Aren't we just taking what we had in the first spot right here? Now notice, you know it, you love it. He's here again. He's been found. Look, we got a code that repeats and repeats and repeats. So when we do this right here, by the previous value, exactly. So originally money vector was of length 1, so there was just one value, but let's just take the first value anyways and make the code very similar as we run this. So if we were to run this right here, we could take this. Is that change? The change right here is the change that we've stored. And so now when we run this, good questions, Charles, right there, times change, exactly. And so what we're going to do now is we're going to talk about how to turn this into a while loop. We want to keep doing this until we have more than what? What would be our condition? I said I want to make $1,000. So remember, the condition is that we need to keep running it while this is true. I want to make at least $1,000. So I want to keep running this in regards to the little star symbol on top of change. Yeah, multiply by change. Yep. Multiply by the change value. So I want to keep running this while what? I want to keep running this code right here while what? Now be careful. There's a lot of ways to say it. Or you could just tell me, keep running this while, just talk to me theoretically. I said I want to make $1,000, so keep running this while what? And then we'll find a way to write it with code. But keep running this while what? Not some, because this is just how much money I currently have. So how could I figure out if I've made $1,000? Like somewhere I could take this vector right here, because we're getting a vector. So there's a few answers to it, but how could I keep running it? So this is a condition right here. I want to keep running it while I don't have $1,000. So kind of close, Meath, but and Trey, good guess right there. 100 points, everyone. I want to keep running it while I have less than $1,000. So what could I check to see in the vector if I have $1,000? There's two answers. I could check the what of the vector to see if I have $1,000. If I've made $1,000, could be checked by doing what of the vector? How would I check to see if I've made $1,000? I could take the what of the vector. Not some. Good guess right there. You could probably do it that way, Meath. That might work. Not some, though, because this is just how much I have starting. That'd be starting after the first hour. This would be after the second hour. So this is how much I have when I'm starting betting after an hour, after 2 hours. So I could just look at the what of this vector. I want to see if I have $1,000. I could just look at a 3-letter word. I could look at the what of the vector. Because if that's $1,000, then I've made it. I could just check the what of the vector. Think the biggest amount. It's another hint. I could just check the biggest amount in the vector to see if I've made $1,000. That'll keep updating. I'll just keep checking to see if I've made $1,000. Have I made 1,000? Check the max. So I want this code to keep running. Be careful if I haven't made $1,000. So my condition is keep running the code. Great job, Charles. We're there and Meath. Not which max, because that'll be the position of the max. We don't want to look at the position. We just want to know, have we made $1,000? What is the max amount of money? Good answers, everyone. So now I want to tell it, if I haven't made $1,000, keep betting. So how would I do that? If I haven't made $1,000, keep betting. The condition should be written what? So this is the wording of it. If I haven't made $1,000, like looked at my maximum, and if it's not $1,000, keep betting. Or if it's less than. Less than 1,000, right? That's how that reads. And that's going to be our condition that goes right here. So this is then going to take, and we're going to start with $100. Now here's what has to change. When we run this, we're going to create an I right here, and we're going to start I equal to 2. Because notice how the first time we run this, I is equal to 2. Or 2 is right there. So I is equal to 2. But inside of my loop, I need to do what now? Inside of my loop, I would need to what? Because this, I believe, is an infinite loop. Let's find out. No. I need to do what? I need to do what right here? Inside of my loop, I need to do what? I need to change the value of... Inside of my loop, I need to do what? I need to change the value of what? Hint, it's always storing to position 2. Change the position, right? So I will become, after the loop runs, I plus 1. So it's going to move I over. Great job right there, Shreya. That might work. We're just going to change the value of I to be I plus 1. So the next time it runs as 3, 4, and follows right there. And then we run it. Oh, man, it's taking a little while to get $1,000. Uh-oh. Let me look at that money vector. Ooh, we got a problem. Uh-oh. I think Shreya might. Shreya, I think you have the answer. Shreya, 500 points. Correct Brian's code. Brian forgot to do something. Shreya, I think you've got it. And Shreya's saying it in the chat. Shreya, I should have looked. You were right, Shreya. 500 points. And Meath is noticing it also because we were still just grabbing the first position. Remember, the first time the loop runs, I is 2. The loop actually ran for 111,000 times. So great job right there. Now we are restarting it, and it ran, and very quickly it came to the vector of the following numbers. It is a lot of values. Let's clear that global environment. Let's remake our money. We're going to go grab our money again. This was a really good example, and this is a lot like the 474 homework. So Meath, doing great right there. Wow, look at that. And then what we could do is we could go to length minus 1, and that's the answer. Oh my God. Length of money. I'm losing my mind. Minus 1, and that's how many times it took us to make $1,000. We could run it again and just see different... Is it really always going to take? Oh, I need to reset the money vector. I got to reset the money. 48, 50, pretty interesting. What we might actually see right here is we'll probably see another normal distribution, because what you could do, and this is the cool part about it, is we could take all of this right here and do what with it? Like if I said, well, let's look at this simulation done 1,000 times. So I'm asking you to what it now. If I wanted to do this simulation 1,000 times to see, well, on average, how long would it take for me to win $1,000 if I start? We can look at a histogram of it running 1,000 times. So I need to sit here all day long, run this 1,000 times, and write down the results, right? I just need to sit here, run it 1,000 times, write down all these results, right? Do I need to do that? Just keep writing down these results 1,000 times? Do you know what I'm going to do? It's going to be a review real quick, then we're going to do some 424 homework. Instead of just doing this 1,000 times and writing down all the results, why don't we just take it, make it a loop? Just go here, drop the code inside of here, reset the money vector, which we needed. We're going to go here for I. Oh, we used an I, so we can't use I. So let's go here, game for game in 1 through 1,000 of our games. Then at the end of this, we're going to store a result. So let's put here result. There we go, results. And down here, we're just going to store this into results of We subtracted 1 because we were off by 1. The second element is after 1 hour of playing, so we just subtracted 1 because second element means we played for 1 hour. Then we're going to store into here of game, and then we'll run it. And that really? Well, I'll be. Well, then let's do it 10,000 times. I want it to take a half second. And there is the simulation of going to Vegas, and it is pretty normal. Pretty cool right there to see that it's a very normal distribution. A lot of statistical theory in play right there with how that will occur. But you notice we did it pretty quickly once or twice. You can look at the summary of it to see there were instances of where it only took you 36 bets to get to $10,000 if you could win 5% an hour on average, and that's an on average thing. So pretty neat right there. Looking at the results, looking at the histogram, seeing what we would expect. But yeah, so we're going to do a little 474 to finish off right here. But great job, everybody. That's kind of the theory behind for loops and while loops. More practice you get, the better. That's how we do it right here. We practice to get better at it. Okay, let's go grab those assignments. Question number 4. Which part of question number 4 are we doing? Which part of question number 4 are we doing? Let's have here question 4. Question 4. Okay, question number 4 is... It's a bunch of multiple parts question. 4B and 4H. Thank you so much, 100 points for being here. Thank you, Josh. Okay, only elements that are 10 or less. So I'm going to do similar but different work again, but it'll pretty much show you how to do them right here. So I think we're taking that's 3. Oops. Okay. Write a command that prints to the screen the following questions. How many movies have a genre that's equal to this? Okay. Hey, Leona. Good to see you here. So we want to look at, and here's the way I'm going to say it. We want the genre of a movie, and you can type this in the chat. We won't type the full answers, though. And you might see what I'm getting at. How could we look at, there's a lot of ways to do this. How can we just look at the genres of movies? Like if we have the movies data frame, clear out my global environment, how could we just look at the genres of the movies? How could we just do that? That's a pipe right there. Close. I know you're going with that, Shreya. And that's what we will do. So if we want to look at, you got it, Josh, right there. Yep, we'll be doing some 7D, I think, coming up here soon. You got it, Chase. So if we're looking at the genre of a movie, we want to look at movie $genre. And there's the genres. Now, there's a lot of ways to do this, especially to confirm the answer. So probably one thing we could do is make a table of it and actually just see what's going on right here. Ooh, some zombie movies right there. So this is a named vector, kind of a lot going on. I'm going to clear the screen and relook at it. So that's a named vector right there. Woo. Ooh-wee. It's pretty crazy. Can I make this look more pretty? Let me try one thing right here. Library, cable extra, cable, and then pipe into cable classic. It's too crazy off the screen. Why is it that far off the screen? Oh my gosh. What have we done? Wait. Oh, did I not do a table of it? Oh, I think I just did the vector. Ah, Brian's brain. Okay. I don't want to do the full vector. I want to do a cable of the table. Okay, there we go. Much prettier. Okay. It still is off the screen, but now we get a much better view of it. This is the cable extra. Just getting work done. Nice job. We can do some 8B. I think we can finish off with that. You got it. So we can see the answers to the question right here, and this is a much better way of viewing it. A cable is a kind of cool table right here. Not yet. Awesome. And so not yet in the soft stars, you bet. And so we can see the answers to the question of what movies are comedy, what movies are, now this is not the answer I would use, but we'll talk about how to get it here in a second, romance, and we can look at the last one, but this is going to show us kind of our answers right here for the question. If we are looking at something like product, let's look at the product data set right here. So once again, Brian does similar but different work. We'll put the disclaimer, don't do everything Brian does, because I'm trying to teach you how to do it, not just show you answers. Remember that. Like, don't just write down all my code. I've seen some people do it and lose points because they just look at the screen and type everything I'm typing. You're meant to be like, okay, what does this do? This loads the product data set, which is not a part of this question. But let's look right here at the product data set and look at the category of product. If I wanted to know if products were A or B, there's a few ways to do this. Let's look at the product and ask the following. Listen to the phrasing. You ready? Is the product category contained in A, B? So try writing that remainder of this out. Here's what I want you to write after this. Is product category, great job, Leona, right there, contained in the vector A, comma, B? And that kind of helps out right here. So now that we have a logical vector, if I want to know the percent or the sum, I could do this or this. Just depends on what the question wants us to do with it. If I want to know the percent or the sum, I could just take the what or what of it. So I have a logical vector. Remember, logical stuff is zeros and ones, because it literally, if you think about how R is viewing this, it's just viewing it as this. So rather than doing as.integer, which we don't need to do, we could just take the what or what of it if we want to know how many or what percent, because it's just a logical vector on the screen. Trues and falses are just zeros and ones, so you can just take the what or what of them if you want to know how many or what percent. Good review. So if we want to know how many, we can just take the what, which depends on what your question asks. Take the mean to know percent. There's the percent, or take the sum. And we could easily find out which ones are not this category by doing not in front of it. So there's a lot of really quick things we can do right here to find out, is the product name or product category contained in this? And think about how that relates to your question right here, where you'd want to know, is the movie genre contained in this vector? So, yep, sum of mean right there. Exactly. Great answers. Does that make more sense on 4B? I didn't quite show the answer, but I hope it makes sense to say, are the movies genres contained in comedy, romance, or thriller? Make sure they're in quotes when you're adding them into your vector, because they will need to be looked for as strings right there. And the next one was number. And great job, Leona and Shreya right there. Excellent work. It was 4. Wait, remind me again, Josh. Oh my gosh. 4H. You're welcome, Josh. Hopefully you get that right there. Let us know if you don't. What is the average value of tomato meter if all entries that are 999 a bogus value or NAs are excluded from the calculation? So there's a data set. Once again, Brian does similar but different work because I want you to kind of follow along and see if you can get it for your question. There's a data set Survey 09 from Reg class. Once again, Brian is doing similar but different work. Time for more coffee. Oh my God, it's Hasm Friday. We need more coffee. Getting some coffee stat. Should put a bunch of riffs from Davey 504 on here. It's one of his riffs. I wonder if he gets like copyright. I should like play a little more, see if he gets a copyright. I don't like a copyright claim from Davey 504. Shout outs to Davey 504. So, what is the average value? Okay. Survey 09 survey says, let's look at number of drinks people had at a party. Now, what's really interesting about this is some people didn't answer the question. Now, some people said what? Besides people not answering the question, somebody said what? Besides 70 people not answering the question, when we said, how many drinks do you have at a party? One particular person said what? Besides the 70 people who didn't answer, because missingness is there for their position, there was a person who said what? Or multiple people, 100. Andre the Giant just taking the keg and just crushing it. Man, you didn't know it? Andre the Giant went to UT, apparently. There's some facts right there. Okay, so I don't think that's real. Frankly, I don't think, even Andre the Giant, I don't think people could have more than, let's say, 50 drinks at a party. So I want to know if somebody answered greater than or equal to 50 drinks. So this tells me, did somebody drink greater than or equal to 50 drinks? And this will tell me the what of people who had greater than or 50 drinks. This will tell me the what of people who had greater than or equal to 50 drinks. That'll tell me the what of people who had greater than or equal to 50 drinks, because I put a which around it. So I have a logical vector right here, and I just threw a which around it. Tell me the positions. Which people? 4 and 5. Person 4 and 5 right here. Person 5 is a male who wants to weigh 6 pounds. 16 pounds. They're almost there. Don't do that. They drink alcohol 7 days a week. This person has 56 drinks a week. Oh man, they got a 1942 car? That's kind of cool. I don't know. What do you think about this data? Oh, they got, I guess, this person only has one Facebook friend. Let's see right here. They do some good studying. They're drinking and studying away. What do you think about this data right here? Garbage. Garbage data right here, I'd say. Pretty crazy data. I don't know about this person 4 and 5. They've seen, maybe it was someone just came in here and messed with our survey. So I think that's some garbage data right there. So you know what we're going to do? We're going to take those individuals. Now, you could do this a lot of ways. You could remove the rows. I wouldn't do that for your tomato meter stuff because the 999 looks to be, I mean, a big movie. I mean, there's going to the movies, studying the movies, drinking. Don't drink in movies. I'm going to store the positions right here. And we know it's 4 and 5. So positions is literally just the vector of numbers 4 and 5. I'm going to go right here to the number of drinks per week. And I'm going to store into there what? What do you think? If I'm just going to change this, I'm going to store into those positions. So I'm going to number of drinks at a party, storing to those positions. And what do you think I'm going to overwrite them with? Take a wild guess what I'm going to overwrite them with. You're going to look for the value of 999. I found people who drink more than 50 drinks. What do you think I'm going to store there? So do it in steps. Don't write the full code. Be doing it in steps like me. Make sure the code's working. Look at what the code gives you. I have the values of 56 and 100. I'm going to overwrite them with what now? Because I don't think these are real. NA, you got a Leona right there. Yep, 100 points. We're going to overwrite with NA. Now, if you go and look at the data set, you can see that the number of drinks per party for these people are missing. Wherever, there it is right there. I think we just saw it. There's the number of drinks at a party. We have deleted their values. They're no longer there. It's not that they're zero. They're just not there. So now it becomes an easier task because now we just have to do the what when we take the mean. So now if I take the mean of this vector, I've changed those values that were absurd values, and I just need to do what for those values now? Just need to do what for those values? Like remove the missing S. Any remove was true. Great job. Huge shouts to everyone here practicing. Chase, Shreya, Yona right there. There we go. So the average UT student drinks about 5.5 drinks at a party. Well, that seems about right. Seems about right. Look at the histogram of it, all that good stuff. But yeah, good stuff right there. Drink responsibly. I have to say that because I'm an adult, but I do mean it. Being an adult is fun. 113.55. Question 7D. Let's go down to 7D. There's 70 questions on this? Oh my goodness. Okay. The table produces, look over here to the chat. The table produces a vector of integers that contain the frequencies of its unique values. Much like each column data set, it's a given name. Okay. Well, we just made a table a little while ago. If you look at the table we made over here, so you have to make a table, and let's say I wanted to find so I've got a cool cable table over there. Check out earlier where I made this cable table. If you're looking for that code to make some pretty tables, what's really neat is you can knit these. Just want to show you that you can make way better tables. This is piping it through to a theme for the table, and you can make really nice tables. It will, I think, show the full table if I were to knit it out, but you can make some nicer tables right here. So R has some really cool capabilities when you break into what it's able to do with some more beautiful tables right there, like looking more scientific than just a basic table instead of R. I'm putting it inside of a cable, and then I'm piping it into a theme for it. So you just say, what kind of theme do you want from the cable package? So that's a neat way to make tables, but we're going to just make the good old-fashioned table right here. So I'm going to do the same thing with movie genre for this. We're going to go table movies and go to genre. And here is a list of the movie genres, which is the same thing we see over here. But let's say we wanted to find out which movies only have one, or which genres only have one movie in it. So how could I see, looking at this, to find out if there's only one observation of that genre? How could I find out if there's only one observation of that genre? How could I find out if there's only one observation of that genre? So I have a table. I want to see if there's only one observation of that genre. This is a named vector, so it's simply just a vector of numbers. I can show it better by saying unname on it, and you'll see it's just a vector of numbers. They're all NAs. Uh-huh. So I am having a big issue with my tomato. Oh, they're all Na's. Reload the data, Shreya. Reload the data. Click the load all data above. Message me if it's still having an issue. Reload all the data. It looks like you overwrote with NAs. Maybe message me your code, but it looks like you overwrote all your values. Reload the data and check your values as you run your code because it looks like you overwrote all of them with NAs. Be careful. But you can reload the data. Good stuff right there. So we have this table, which is just a named vector, and Leona right there, great answer. We can say equals 1. Yep. So that will tell us if it has a value equal to 1. Now I'm going to throw a code around it. And I want to know what this code is going to do to this logical vector. What is this code going to do to this logical vector? Thank you, Shreya, right there. What is this code going to do with this logical vector? It's just going to tell me the what's of the what's. Because I have a table. You're seeing the code of the table right here. And now I'm just going to get the what's of the what's by throwing a which around it. I want to know which ones are what. What will it do? I want to know which ones are what. Throwing a which will get you the positions of the kind of which ones are true. So it's going to tell me the return of this. Whew, nice job. The return of this will be a vector of the what's of the trues. The return of this code by putting a which around this will be a vector of the what's of the trues. And hint, you can look at the which and it kind of gives you hints. You're welcome, Shreya. Great work. Good practice, Shreya. The return of the which will be a vector of the what's of the trues. Good practice. Like, you just have to know what the code does. That way you can have it in your toolbox of code you're using. So it says indices, but I usually call them starts with a P. 100 points on the line. A vector of the what's of the trues. Positions, great job. So it's going to tell me the positions of the trues. So a lot of times, and that's not how many are in the movie genres, well, that's not good. Monster, space, and zombie all have one movie in that genre. So you can see this by taking the positions and going back to your table and only taking those positions right there. Does that make sense? So it's not that there's 18 monster movies. It's that there's one monster movie and it was in position 18 in the table. And you can see it right here because I think they're in alphabetical order. Zombie is in position 13 and there's one zombie movie. It's the 13th value in the table. There's one space movie, which is in the 24th position in this table over here. We also have the table over here to show it and just to see visually what's going on. So you can see there's 2 right here. If I had done 2, concert would appear and it'd be 1, 2, 3, 4, 5, 6. So if I run this, it's going to tell me there's 2 position, or concert, which is in position 6, because there's 2 observations, and then returning this returns the value in position 6. Does that make more sense what this code is doing right here? So to get the names of the genres of movies that appear, then you could just run names. Yeah, you could just, well, you could technically just go right here and go names. There you go. Oh, there's only, yeah, that's for the concert. And then if we go right here and do this, or go 1, there you go. Just run names around it. That works too. Does that make sense right there, Chase? Those are the names of the movies, and we can confirm by looking at this that we have the names of the movies that have 1 observation. So that's the names, and it's just getting the positions. Lots of ways to do it, but that right there. Does that make sense? Doing well? Double check your code as you run it. Like, don't run everything. Don't just type everything at one time and be like, it's going to work. Because even I'll make mistakes here and be like, wait, what did that do? What did I get? What am I finding? What am I looking for? Why are we here? Just to suffer? I don't know. Okay. Last question. Leona, I think you're wondering about 8 something. 8 something it was. Remind me. 70. Which one is it? Yeah, great job, Leona. And so, yeah, seeing this again right here probably like makes more sense. Great job. 100 points in the chart there. Those are the names. Throw names around it. Yep, 8B. Let's look at 8B. Okay, let me put a note right here. Thank you so much, everyone, for being here. We've had a fun-filled day. Look at all this work we've done today. Woo! All the work. That means no more work, right? 8B. So 12103. BS first favorite. 8C. 8C. And B and C, or B. You want C. Okay, good. Homework 1. question 8C. Let's check it out. So question 8C says to us, it's the condition stuff. Okay. So we want for each one of these conditions right here, how many? Can we both? Yeah, let's do both then. Let's do B and C. B and C. Okay. Let's look at B and C. We're right here. So define prices fixed to be the vector of values contained in by price. So you want to take and store into, I'm not going to quite show it completely, but you want to take and store data frame $ variable. That should kind of make sense right here. You're just taking and defining right there. Let's get rid of some of the problem values and perform a simple median replacement at which is a guess if the missing values are found by using the median as replacement. Replace all values in prices fixed that are greater than 100 with missingness, and don't put the missingness in quotes. So we kind of did something similar here with the drinks question. I'm trying to think of another thing in the data set. Like, let's look at how often people sleep. So let's pull up the data set survey. Once again, Brian's doing similar but different work. Disclaimer, disclaimer. You're welcome, Chase. 100 points. Thank you for being here. Drop by with any questions you have. Wait. Trying to load vector. Okay, so hours sleep. Okay. So what do you notice if this is the hours people sleep? What do you notice right here? What's the first thing you notice about this? What is the first thing you notice right here with this vector of how many hours people sleep at night? What is the first thing you notice? Well, the mean. 6.89. Apparently, Brian, 6.89. Brian needs to sleep more, apparently. Apparently. Maybe. But look at this right here. The max. Someone said they sleep 24 hours a night. So that's like, do you really? 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 I'm talking to you right now. I don't think you're asleep. Must have been a good day, right? This is on average. Like, how many hours do you usually sleep a night? And they're like 24. And you're like, then you wouldn't be answering the survey. And they're like, I'd get up for 1 minute to answer surveys online. I'm very envious of that person. So let's do the following. Let's find out if people have values. What is a ridiculous amount of sleep? Like, when would you start doubting someone? Like, if someone said I sleep 12 hours a night, I'd probably be like, it's a lot. I mean, not even like, hey, it's a lot, but like, that's a lot. I mean, it's not a lot of people sleep 12 hours a night. But if someone said this, you'd be like, I don't believe you. Like, if someone said I sleep 24 hours a night, I'd be like, no. When would you not believe somebody? Like, you would just instantly doubt them. You'd be like, no. When would you doubt somebody? 100%, like, that's impossible. I mean, of course, 25 is impossible, but I'm going to doubt 24. I'm doing a theoretical version of this question where we just come up with an impossible value and replace it with the median. So we're going to replace values right here with the median. So what would be impossible? Or not impossible, but just we wouldn't believe. So you can just come up with any value. Don't say something like 8, because I'd be like, 8? You don't believe 8 hours? Someone says to sleep 8, and you're like, what? 10 to 12, 13. Let's go for 13, because that's a little more than half the day. So someone's sleeping more than half the day, and this is like on average. It's not like they slept one night for 13 hours. It's like they're saying I usually get 13 hours of sleep a night. I mean, it's possible. We're just going to say that we start to think people are lying around there. We have more reason to believe they're lying than they are telling the truth. I'm sure there are people who sleep 13 hours a night, but we do have some individuals right here, like this person reporting that they do sleep 13 or more hours a night. So now let's go ahead and find the whats of these individuals. You can do this a lot of ways. I like to do it with this step right here. Let's find the whats of these individuals. I guess technically it works if you don't do this. So I'll show you. If you have a logical vector, you could just return, by doing this here, num sleep, hour sleep. You could just return the values in those positions with that. So if you have a logical vector, it works without the which. I throw it in a which sometimes, but the logical vector of trues and falses will still return what's in those positions. So I first would like to do this. I'm going to just remove those things there. So how can I just remove those things? How can I just make them disappear? I'm like, we're just going to scratch out what you wrote. And I'm going to write the code right here to do it. So I saw what those positions are, like they're 24, 24, 13. So we're going to do the NA, and we're going to store an NA into those positions. Now I want to find out where my NAs are at. So now if I want to find out is something NA, hint, how can I look to see if is something NA in this vector? How can I see is something NA in this vector? Like, is it missing? How can I ask R, like, are there things missing in that vector? Or where are they? Are there things missing in that vector? How can I do that? Is .na, yeah. Is it NA? And then we go over here, create the owner right there. And let's take and store this as positions again. I'm going to overwrite what's in positions. And I'm going to go to those positions. Actually, we have it right here. So now we have the positions of the missingness, which are the same things. So we just found the same things. There might have been more missingness. Like there might have been missing values that existed before I did this. There are some missingness in this data. But now I'm going to overwrite those missingness values with what? Now I'm going to overwrite the missingness values with the what of the vector, which is what the question wants you to do. It's up there at the very top line, 281. I'm going to overwrite these values with what? Will this work? Will this work? You can find out here, and the answer is going to be, will that work, yes or no? We're going to use the median, and will this work right here? It won't work for a specific reason because there's missingness. So we have to go here and do the following. Now we can see we overwrote those values, and now we can check our vector. Summarize new. There we go. Is that making sense? Now the maximum value is 12. We need to do the NA. Isaac, great to see you here, and you're right. We need to do the NA.remove equals true. So there's the steps right there to do it. Very similar problem right there with working through the data and replacing some missingness values with the median. Here, we'll do a logical check right here. So let's say we wanted to look at something like speeding tickets. And I think this data set has a speeding ticket question. And we want to figure out if things in the Survey 10 data have speeding tickets. I thought we had speeding tickets. Use chopsticks. Weekly asset. Let me think of one more variable. Hours you work a week. Okay. So when you think about hours people work a week, now it can get pretty crazy, but hours people work a week probably shouldn't go more than what? This is how this question works with checking to see if things violate constraints. Hours people work a week probably shouldn't go more than what? I mean, it can't logically go more than 168, which is 7 times 24. But hours people work a week probably... Gotta be careful, though. Well, well, a lot of people work a 40-hour work week. But this is how many hours did you work last week? Or, like, work in a week? 40... A lot of people work more than 40. There's... When I worked at Cheddar's, I had 1 week where I clocked in over 100 hours, and they actually got mad at me for what I was getting paid with my server wage because I hit, they paid you like time and a half when you hit 40 hours, you got time and a half, and I worked a double every day. Like I literally worked a double every day, and I was like shift leader. So I think I was going in, I worked like literally every day. So I was going in at like 8 or something like that, like getting the restaurant started, and I was leaving at like 12:30. So I was maybe I was working, there's 4, there's 16, so 16 times 7. So that's 42, is it? So I think I worked like 112 hours or something. Like I was just going home, sleeping, like sometimes throwing things in the wash and just getting a new shirt on and going back into Cheddar's. And then I remember my manager, Frank, was like, how did you clock in over 100 hours? And I was like, I've been here every day this week. And they're like, why are you working so many doubles? And I was like, I picked up shifts. They were like, what are you doing? I was like, I don't know. I get a shift meal if I'm shift leader. So I'll hang out, watch people clean their tables, help out. And I thought I was pretty good at the job. I liked waiting tables. Yeah, so it was pretty crazy. And they were kind of not happy because if you do time and a half it was something like story time with Brian right here. I got like 70 overtime hours, times that by time and a half, add on my 40. So I got something like that, put my server wage of about $2.80. And they're like, how did you make a paycheck of $400? Of course, then you're taxed on it. But they were like, how do you actually have a paycheck on a server wage? Like, and that's not a great paycheck, but yeah. Oh, it was crazy. It was crazy. So anyways, you could work 100 hours. Point being. I don't really think my mom, most hours of work is 70 on a week while I was doing associate. Yeah, exactly. You work a lot of hours. Please take care of yourself. I've probably worked too much at times. I don't know. I was younger back then. I had my spirit back then. Haven't broken yet. Let's say we want to see if someone's worked more than 125, because at that point, I don't know if you're really sleeping. 125, like I worked every double, and 125, you only have, what is it, 43 hours divided by 7. You're only getting like 6 hours outside of work. So I don't know, 130. That's about as ridiculous as I can go. So when we run this vector right here, this is if somebody works more than 130. But could someone work 0 hours? Is that a logical value? Could someone work 0 hours? Or are these people lying? Could somebody work 0 hours? Is that theoretically possible to work 0 hours? And this is how you do this question right here, looking to see if there's violations of possibilities. Could someone work 0 hours? Or is that, no, you can't do that. This is like a job we're talking about. But it's like you could not have a job. So I'm not trying to trick you. Sometimes my questions are as simple non-coding questions as there can be. Can you work 0 hours? Well, yeah, you just don't work. So it was like someone say I work 0 hours. Say, okay. So let's see if a person worked, yeah, if you don't have a job. Yeah, exactly. So now look at this. My code is asking if people input values what? Try to make sense of my code right here, especially with this little pipe thing right here called an OR. So I'm asking, when someone answered my survey, did they? So think about this, because these would be values that I just don't think should exist. So if I'm looking through my survey, kind of, we could do between, but I'm actually looking for violations of the conditions. So it's not that they're between it. It's actually the outside bounds. Trey, good job, work right there. So it's not that they're between the values. It's that they have greater than or equal to 130, or they have less than 0, because less than 0 is just theoretically not possible. You can't work negative hours. So what you can do with this then is you can take everything right here, and I've now found what? What did this code now find for me? So by finding out the logical, exactly, Leona right there, great job. I'm pronouncing it right, Leona, right? I'm sorry, I want to get everyone's names correct. I think I've already asked that twice now, I'm sorry. But with this right here, I'm now finding what for this condition. Because I just took a logical vector and I found the sum of it. So I found out how many things... Oh, I'm not? Oh, please correct me. Oh, no. If you put phonetic, I'm going to practice it and make sure I get it down. So... It's an I to start, right? So is it Lana? If you put it phonetically in the title, make sure to practice. Thank you for saying that. It actually brings me anxiety when I get names wrong. And so I usually just get worse. So I usually try to sit down and look at the name and say it like 5 times in a row. Elena. There we go. You got it, Elena. Thank you so much right there. Isn't Elena on Vampire Diaries? Isn't she not Stefan and Elena, but what's his name? Ian Somerhalder. Elena and why can't I think of his name? Elena and translation issue. Okay. Elena and Damien. There we go. Elena and Damien on Vampire Diaries. Does that make sense right there? We can take the mean of it to find the percent. We can take the sum to find how many. And that's how we got it right there. Damon? Yeah. Was there one more? Was there one more question right here? Was there one more? That does that one. Explains how to do it. I'll probably head off here in a moment. We've done a lot of really good work. Was there a question on like 9 or something, did people say, or 8? Did we just do 8? We talked over the theory behind it, but let us know if you have questions. I've got a lot of questions on Discord, I noticed. I'm going to drink a Coca-Cola here in a moment. But any last questions? We're going to head off here in a moment. We have done a lot of great work today. So with that, big thank you to everybody. All the notes are coming up here. You're welcome, Shreya. Thank you, Elena, for being here. So we have all the notes we're going to put in the videos. I'm going to go do that now real quick. Till then, bye for now. A lot of BAS. More coming up next week. Bye, everybody.